Welcome back to our special series on electromagnetism. In this segment, we'll be discussing adaptive beamforming technology, its applications in jamming scenarios, and the ethical and legal implications of using such technology. Joining Joanna is our expert, Ruth, who will provide insights into this advanced technology.
Ruth, can you explain what adaptive beamforming technology is and how it works?
Certainly, Joanna. Adaptive beamforming is a sophisticated technology that uses a phased array of antennas to direct radio frequency, RF, energy in specific directions. It involves continuously monitoring the environment and adjusting the phases and amplitudes of the signals in real time to optimize the direction and strength of the beam. This process is managed by sophisticated algorithms that process incoming signals to determine the best configuration for the array, achieving the desired jamming effect.
How is adaptive beamforming used in jamming scenarios, and what are its advantages?
In jamming scenarios, adaptive beamforming can be used to more effectively disrupt communications or other electromagnetic signals. By focusing the jamming signal precisely on a specific target, adaptive beamforming maximizes disruption while minimizing interference with other systems. For example, in military operations, it can be used to jam enemy communications, radar, or navigation systems while avoiding interference with friendly forces. Additionally, adaptive nulling creates areas of low interference to avoid jamming critical communications.
Can you give us some real-world applications of adaptive beamforming in jamming scenarios?
Certainly. In the military, adaptive beamforming enhances electronic warfare capabilities by allowing precise and adaptable jamming. It's also used in counter-drone systems to jam the control signals of unauthorized drones, providing focused disruption while minimizing collateral impact on other electronic devices. Another application is in anti-surveillance, where adaptive beamforming is directed at specific devices or areas to create targeted interference, preventing effective monitoring.
What are the technical challenges associated with adaptive beamforming in jamming scenarios?
Implementing adaptive beamforming requires sophisticated hardware and software to manage real-time adjustments and signal processing. Effective jamming often requires high-power signals, posing technical and safety challenges. Additionally, identifying and targeting the correct frequencies for jamming is crucial, and the system must be capable of switching frequencies as needed to counter adaptive adversaries.
Let's discuss the ethical and legal implications. What should be considered when using adaptive beamforming for jamming?
Jamming devices are heavily regulated due to their potential to disrupt critical communications and services. Unauthorized jamming is illegal in many jurisdictions. Care must be taken to avoid unintentional interference with legitimate and critical communications, which can have serious safety and operational consequences. The use of jamming should be carefully considered and justified, particularly in civilian contexts, to avoid infringing on rights and safety. Ethical use of adaptive beamforming for jamming must balance the need for security and operational effectiveness with the potential impact on civilians and noncombatants.
Thank you, Ruth, for explaining adaptive beamforming and its applications in jamming scenarios. In our next segment, we'll discuss the accessibility and feasibility of average citizens acquiring and using advanced electromagnetic devices. Stay tuned as we continue to explore the fascinating world of electromagnetism.